This video is just to go over some of the aspects about the vocabulary of an absolute value function. So we have a couple of things that we need to consider. We're going to start off by just looking at the standard absolute value function. And there are a few things here that should not surprise us. Specifically, if we recall from earlier in the year, all the absolute value function is it's a function that takes any number that is negative and makes it positive, and it takes any number that is not negative and leaves it the same. So what it's measuring, what this function measures, is the distance away from 0. So like 2, the number 2 is a distance of 2 away from 0. Now, there are a couple of parts on this absolute value function that are important. The first one is the vertex. And the vertex is basically, the exact definition is that it's the point that lies on the axis of symmetry. What it basically translates to is it's the point where the absolute value function switches from having a negative slope to having a positive slope, or vice versa. So if the absolute value function was reflected, it would be when it goes from having a positive slope to a negative slope. It is the point that is on the axis of symmetry. And here's the important bit about the axis of symmetry. If I take any point on my absolute value graph, so that point, this distance here is 2. So if I go a distance of 2 on the other side of the absolute value function, I end up with a corresponding piece of that absolute value function. And this is true at every location. Here, I'm a distance of 4 away, which means if I go a distance of 4 on the other side, I end up back on my absolute value function. These are the 3 essential things about our absolute value function. It has a vertex, it has an axis of symmetry, and that axis of symmetry defines the overall steepness of our absolute value function. So let's graph a couple of these. So what we're going to do first is we are going to graph using a table. And if we're graphing using a table, the first thing we need to do is we need to identify what our axis of symmetry is. And we use that axis of symmetry in order to plot the rest of our points. So to find the axis of symmetry, we take whatever's inside of our absolute value function and we set it equal to 0. So x minus 1 is 0, and we just solve for x. X is therefore equal to 1. So that is my axis of symmetry. All that value tells me is the middle x value I choose. So what I have here is a table set up to give 1, 2, 3, 4, 5, 6, 7 x values. So that fourth x value, I'm going to make a 1. And what we do to figure out our y values is we take our x value and we put it in. So 1 minus 1 is 0. The absolute value of 0 is 0. 0 times 2 is 0. 0 minus 3 is negative 3. And this point is actually our vertex. So from the previous little bit, you notice that we got the definition of a vertex, which is the point that is on the axis of symmetry. Since we chose an x value that is the axis of symmetry, that's why we end up in this case. Now, we need to pick the rest of our x values. And when we are dealing with most of our absolute value functions, we can just choose a number that is 3 larger than our axis of symmetry. So that would be 4, 3, and 2, counting down toward our axis of symmetry. And then we continue counting down past that. So 0, negative 1, negative 2. Okay. Now, to get each of these, we take the x value, plug it into the absolute value function. So 4 minus 1 is 3, absolute value of 3 is 3, 2 times 3 is 6, 6 minus 3 is 3. And we do the same thing with our other values. So if we plug 3 into this function, we're actually going to end up at 1. And if we plug 2 into this function, we're going to have a value of negative 1 at the end. We can continue going this route. So we can continue plugging these x values in. We also know that this is the axis of symmetry, meaning as long as this distance is the same, then these values will be the same. So 0 is a distance of 1 from 1, therefore I look at the value for 2. We keep going in this manner, so it would be 1 and 3. And there's our absolute value function. And from here, it would just be we go through and we connect the dots, remembering to change our direction at the vertex. So we end up with that classic V shape that is the graph of an absolute value function. And this is really useful in the sense of it can be very easy to create or straightforward to create the table. It is, however, not always what you want to go and try. So we have one other way of graphing these, and that's to use graph transformations. And here's essentially what happens when we deal with graph transformations. we have our parent function. So this is the most basic form of the absolute value. And then we shift this left and right, up and down, based off the values that are here. So x plus 2 tells me that I actually need to move left 2. Because remember, this bit we would normally set equal to 0 to find our axis of symmetry. And then this would tell me to go up 4. And from there it would just be applying the steepness. Now, let's approach this by finding the axis of symmetry, which, as we stated, was just do x plus 2 is equal to 0 and solve, and we end up with x equals negative 2. And then if I put negative 2 into my absolute value, that gives me a positive 4, which means that my axis of symmetry, or my vertex, is negative 2, 4, and my axis of symmetry is negative 2. So there we are. I have those two bits there. Now, we are going to identify the steepness. And the way we identify the steepness is we are going to look at the number in front of our absolute value expression. And we're going to treat this like it's a slope. Now, this tells me the slope of the part of the absolute value that is to the right of my axis of symmetry. So this is down 2, right 3. So at every single one of these, I'm going to go down 2, right 2, 3. And then I'm going to go down 2 again and right 3. And we can keep doing this as many times as we feel we need to. Okay. Now, we don't do that same steepness over here. Instead, what we can think about is this is a distance of 3 away from my axis of symmetry. So I'm going to go 3 on this side to get there. This is a distance of 6 away from my axis of symmetry. So I'm going to go 6, 2, 4, 6 in this direction. And as you can see, this last point I wouldn't be able to put onto this particular graph. Okay, at this point we just go through and we draw our lines through the points, making sure to shift at the vertex. And that should look like that. So to summarize, this video discussed 3 things. Talked about the basic vocabulary that revolves around the absolute value function. Then it talked about how to graph an absolute value function using a table, and how to graph an absolute value function using transformations. All of these setups can be used to allow us to visualize the absolute value and kind of see what is going on with it. That is going to wrap up our discussion for this video, and I will see you in the next one.